let's talk about limits. Let's say we're given this red curve f of x and we're asked to find what f of 2 is. Here, it should be pretty obvious that at x is 2, the y value would be 3, we would say f of 2 is equal to 3. Now we'll repeat the same process, but this time we have a hole at x equals 2. What would we say f of 2 is equal to? Well, we'd say that this does not exist. Now we'll do this again. The function still has this hole here, but I've gone ahead and put a point up above here at y equals 4. So if you were to ask, what is f of 2? In this example, we would jump up to the point that it's defined at, which would be 4. Now imagine if the region around x equals 2 was blurred out. We didn't know what was occurring there. What would you guess would be the value of f of 2? Well, what we see is that as I get closer to x equals 2, the blurred region, my function gets closer and closer to this height y equals 3. Right? From the left side, my graph comes closer to this point, and from the right side, my graph also gets closer. So I would take a guess and say that the y value here might be 3. This is the idea of a limit. It tells us the y value we get closer and closer to as our x value gets closer and closer to a number. In this case, as I get closer and closer to x equals 2, my y value got closer and closer to y equals 3. Now, while I don't know if f of 2 is really equal to 3, I do know that as x gets closer and closer to 2, my function gets closer and closer to a value of 3.